Good afternoon, class. Today we will be talking about finding and using the slopes of lines. This is section 4 of chapter 3. At this point, we are going to kind of switch our focus. We've been talking about transversals and parallel lines at this point. However, now we're just going to look at lines and how to figure out their slope. The goal for today is that you will learn how to find the slope of a line and how the slope of parallel and perpendicular lines relate. So the big idea here, slope of a line, it's how steep the line is. So it can be thought of the steepness of a line. If it's steep, let's see, I gotta make sure I'm doing this right. If it goes up to the right, which for you that should be this over here, which is actually the opposite for me. It's going up to the left for me, but up to the right for you, that means it has a positive slope. It's going to have some sort of number. If it's straight vertical, it has undefined steepness. It's so steep we can't define it. But anything other than straight up and down, it has some sort of steepness. When it's flat, it's not steep at all, any way whatsoever. So we could call that zero steepness. And when it goes down, it's getting less steep. However, it is still getting steeper and steeper and steeper, because you could have a really downward steepness, and that's still steep. The slope of a non-vertical line is the ratio of the vertical change. How much is it changing up and down to the horizontal change? How much is changing left and right between any 2 points on the line? M here, this M stands for slope. Okay, that's all it does. Slope equals rise over run. How much does it rise for how much it runs? It's also thought of as the change in y over the change in x, which we write it this way: y2 minus y1, x2 minus x1. If I'm given a set of coordinates, I plug them into that, and I can tell you the steepness or the slope of the line that would run through those 2 points. If I look at different types of slope, line M here has a negative slope because it's going downward as I move to the right. It changes down as it runs to the right. Okay? So therefore, it's a negative slope. N has a positive slope because it rises as it runs to the right. And P has zero slope because it's a horizontal line. It has zero steepness. No steepness, no slope. Zero is no. At least in this case. And Q here is undefined because how can you call that steep? It's a vertical wall. I mean, if it was anything but vertical, you could say extremely steep or great steepness. But when it's vertical, it's really not steep anymore. It's now a wall. You don't say that wall looks steep. You might say that wall looks high, but you're not going to say that wall looks steep. The next thing that we need to talk about is actually a theorem. Slopes of parallel lines. So this was something I probably put in my theorem section. It actually has a name, so you need to know it. 2 non-vertical lines are parallel, and here's the thing. It's an if and only if. It means it goes both the original way. 2 non-vertical lines are parallel, then they have the same slope. And it also goes the other way. If they have the same slope, then they are parallel. So 2 vertical lines are parallel if and only if they have the same slope. They did have to make a clause there. Any 2 vertical lines are parallel. So in this case, line M and line N are parallel because they have the same steepness, the same slope. Line Q and P are parallel because they are both vertical. The next theorem is slopes of perpendicular lines. 2 non-vertical lines are perpendicular if and only if the product of their slope is -1. So if I would take the slope of M here and the slope of N, they are only perpendicular if I could multiply their slopes together, and it would equal -1. Also, line P and Q here are perpendicular because they're horizontal and vertical. So you should be able to describe slope, identify slope of parallel and perpendicular lines, and in the example video, that's where you're going to see some of these examples. If you know how to use rise over run because of last year, go ahead and use it. If you know that parallel lines are the same slope, same steepness, go ahead and use it. If you know that perpendicular lines have to have their slope multiplied to be -1, great. Otherwise, please look at the example video. Till next time.